Hi everyone, let's solve question number 39. For our set S, we denote by S dash the complement of set S. Let X, Y, Z be sets such that Y is a subset of S. X. Which of the following is always true? So let's try to see options one by one. Okay. So the given condition over here is Y is a subset of X. So let's say this is our X and this is Y, right? So this is what we have been given. Now, which of the following is always true? Let's say this is our universal set. X intersection Z is a subset of Y intersection Z. So let's say Z is somewhere over here. This is Z. Now, X intersection Z and Y intersection Z. In both the cases, Y intersection Z is this one. X intersection Z is always greater than or equals to then Y intersection Z according to this Venn diagram, right? So this is not correct. It cannot be a subset of Y intersection Z, and that should have been the reverse condition. The best case would be the Z is not at all intersecting with both of them. In that case, both the sets would be equal. That is null. But that is the best case. In all other cases, it would be a subset. X intersection Z would be a superset of basically Y intersection Z, right? So A is not the correct answer. Now talking about let's talk about option C first. B and D are special cases. So let's talk about option C first. X intersection Y union Z equals to this. So let's try to break it down further. This is written as X intersection Y union Z, right? Now what I'll do, I'll open it with distributive property. So basically I'll be getting X intersection Y union X intersection Z. Now X intersection Y. X intersection Y would basically mean Y only because Y is a subset of X. So the common points are Y only. So basically that gives me Y union X intersection Z. Now if we compare it with this one, we are getting over here Y union X intersection Y. Right? So these two are not equal again. This is not correct. Now let us talk about the B option. Okay. Now one thing to observe over here, let me make it clean. One thing to observe over here is if Y is a subset of X, so that would mean Y dash would be superset of X. Basically, X dash would be a subset of Y dash, right? Because Y dash would be all these elements, and X dash would be just these external elements, right? So if that is the case, that basically means X dash is a subset of Y dash. So let's call it X dash as A and Y dash as B. So the given condition is A is a subset of B. The modified condition, not the given condition, the modified condition is A is a subset of B, right? Now they are asking B intersection Z dash is a superset of A intersection Z dash. Right? Now let's again call Z dash as C. That would give me B intersection C is a superset of A intersection C. This is what they have been asking, right? Now again, same logic as the A option. If A is a subset of B, in that case, A intersection C would always be a subset of B intersection C. So this seems correct, and D option is more or less the opposite of B option. So B is our correct option.